Okay, so today I want to talk with you guys about how to convert between moles and molecules. Okay, so between moles to molecules, and then from molecules to moles. Okay, and the key to this is that unlike yesterday when we went from grams to moles and moles to grams, we had to get the molar mass, and we had to get a different molar mass each time. Today, you only need to use one conversion factor, and the conversion factor that you use is that one mole equals 6.02 times 10 to the 23rd molecules. Okay, so that's the only conversion factor that we'll use today. And again, remember, it can be, depending on which way we're going, it can either be 1 mole over 6.02 times 10 to the 23rd or 6.02 times 10 to the 23rd molecules per mole. We can have either one of those. So now let's sort of just devise a problem. Let's talk about going from molecules to moles. Okay, so put that up on your notes, and then here will be an example. If you have 2.63 times 10 to the 25th molecules, how many moles do you have? Okay, so write that problem down. You have 2.63 times 10 to the 25th molecules. How many moles do you have? Okay, how many moles do you have? Okay, again, we're going from molecules to moles. And again, if you have 2.63 times 10 to the 25th molecules, how many moles do you have? Okay, I'm going to show you how to set up that problem now. Next slide. So you start out by writing 2, here let's use the other ink, 2.63 times 10 to the 25th, and I'm not going to put molecules, but it should be, well, I'll try, but I'm going to run out of space. Molecules. Okay? And then I have to then multiply this by a conversion factor. So the conversion factor is that, remember, we want to get moles at the end. So we write 1 mole. Turns out it's by 6.02 times 10 to the 23rd molecules. Okay, so that's the only number we use. And now when we go to do this, it looks like molecules will cancel, and this will then give us moles. So it appears that we have to take 2.63 times 10 to the 25th molecules and divide it by 6.02 times 10 to the 23rd. Now if you do this on your calculator and you know how to use scientific notation, when you divide these two numbers, what you end up getting is 43.9 43.7 moles, okay? 43.7 moles. So if you have 2.63 times 10 to the 25th molecules, you'll end up with 43.7 moles of that molecule, whatever that molecule turns out to be. Okay, so again, see if you can do that on your calculator. I'll give you about 30 seconds on your calculator to do that. And again, this problem makes sense because it looks like you have a larger number. 10 to the 25th is larger than 6.02 times 10 to the 23rd, so that makes sense that you have greater than 1 moles. If this number here was smaller, 25th, if it was smaller than 23rd, like if it was times 10 to the 22nd, then this number would be less than 1 mole. It would be a smaller number. Okay? So again, the answer to that is 43.7 moles. When I get back, if there's still some of you that are having difficulty with using your scientific notation button on your calculator, we can go over that. So the next thing I want to show you is how we're going to go from, if I give you moles, and we're going to go to molecules, okay? So write that down, moles to molecules. So a typical problem might be, say, you have 0.5, let's do that, 0.567 moles of CO2. How many molecules, put it in the other line, how many molecules is this? One of the ways they try to trick you with these problems is by actually giving you a chemical. But whenever you see moles and molecules or molecules and moles, the only conversion factor you're going to need to use is Avogadro's number. So this doesn't matter, the CO2 doesn't matter. You don't need to worry about that. You just have 0.56 moles of something. How many molecules is this? That's really what the problem is seeing. The CO2, or if they say potassium sulfate or whatever it is just trying to misdirect you. It doesn't matter. It could be you have 0.567 moles of, I don't know, moles of cars. How many molecules, how many cars is this would be the question then. Okay? So anyways, write that down. So now I'm going to show you how to solve that problem. So just like before, you start by writing 0.567 moles, okay? And then you make our thing here. And then now moles has to be on the bottom, and molecules on top, and it's 1 mole, and it's 6.02 times 10 to the 23rd molecules. Okay? It's that simple. Moles cancel, so you're basically multiplying 0.567 times 6.02 times 10 to the 23rd, okay? And that will give you the molecules. Okay, I'll give you 15 to 20 seconds to do that problem, and we'll see if you get the answer. If you think about it, it's going to be slightly more than half of Avogadro's number. Okay, slightly more than half. Okay? So again, just remember that when you're going from moles to molecules, you multiply by Avogadro's number, and when you're going from molecules to moles, you divide by Avogadro's number. Okay, so this is the answer that I got. 3.41 times 10 to the 23rd. And this would be molecules, put a C there, and it's molecules of CO2. You didn't need to do the molar mass of CO2, but you simply need to recognize that it's 3.41 times 10 to the 23rd molecules of CO2. Okay? Okay, so let me just summarize. If you're going from moles to molecules, you basically take moles times Avogadro's number, Avogadro number, okay? And if you're going from molecules to moles, you simply take molecules divided by Avogadro's number. Okay? So that's it for this little mini lesson. There will be homework number 41, which the substitute will now hand out, and that will be due on Friday along with number 40. Thank you, and see you on Wednesday and or Thursday.